Hello everyone, welcome to Maths Bridge. We train and learn. Let's learn R programming. Hi,
Hello,
thanks for joining.
thanks for inviting me.
So today what you would be explaining us?
Today our learning goal would be R Toolbox for Statistics, why R applications, R for data analysis, features of R, how R works, R programming concepts, R data interfaces.
That's great. Let's get started then.
R was started in early 90s by Professor Ras Ihaka and Robert Gentleman as a programming language to teach introductory statistics at University of Auckland and New Zealand. Robert and Ras teaching lab had Macintosh computers for which no suitable commercial environment was available. Hence, they created R programming language. R is a programming language and software environment for statistical analysis and graphical representation and reporting.
R programming language for statistics. Statistics is a science concern to develop and study methods for collecting a data, analyzing the data, infer the data and extract the outcomes from the data. So statistics is used in wide variety of applications in the real world. You know that, right?
Yes, of course. Statistics can be used into plan budgets, determine the best routes, predict the patient's conditions.
Statistics is used to conduct research, evaluate outcomes, develop critical thinking and make appropriate decisions to sustain the business growth.
Statistics can be used to understand why things happen, when they occur, and whether reoccurrence is predictable.
That's correct. So now R is a software programming language which we use in statistics for the better future.
R Toolbox for standard statistical techniques. R can be viewed as programming language that happens to come with a large library of predefined functions that can be used to perform various tasks. R is a GNU project and it is free and open source software. R is growing exponentially by most features. Most estimate count over a million users. A major focus of these predefined functions is statistical data analysis, and these allow R to be used purely as a toolbox for standard statistical techniques. It has over 4,000 add-on packages contributed by the R community. The TOB programming community index of language popularity placed R at number 24, roughly on par with SAS and MATLAB. Why R? R is an open source programming language and it is freely available under the GNU General Public License, and pre-compiled binary version of R are provided for Linux, Windows and Mac. R is an interpreted language. R comes with a command line interface and provides a vast list of packages for performing tasks. R is a platform independent. R supports both procedural programming, object-oriented programming. R is powerful platform for interactive data analysis and exploration. In data visualization and data manipulation, we use R. Applications of R programming. R is used in field of data science, statistical computing, machine learning.
Yes, some of the applications of R: stock market modeling, fraud detection, business intelligence, weather forecasting, sentimental analysis, behavioral analysis, data science, statistics, scientific methods, data analysis, artificial intelligence. All these areas where you can see R programming.
R for data analysis. In this, we have data learning model. It is a computational model that learns patterns and relationships from data to make predictions or decisions, and it enabling automation and intelligent decision making in various applications.
We have various analytics like descriptive, diagnostic, predictive, prescriptive.
In descriptive analytics, we see why happened in the past. In diagnostic analysis, focus on understanding past events.
That's correct. Things like that, what happened, when did this happen, can be studied in diagnostic analytics.
Predictive analysis focus on forecasting future outcomes.
That's true. What will happen should be known in predictive analytics.
Prescriptive analysis focus on recommending actions to achieve desired outcomes.
Right. Surely we should say how to make it happen.
Together, these analyses enable organizations to gain insights and make informed decisions and drive better outcomes.
Well said.
How R works. R is an interpreted language, not a compiled one, meaning that all commands typed on the keyboard are directly executed without requiring to build a complete program like in most computer programming languages. R syntax is very simple and intuitive. When R is running, the variables, data, functions, results are stored in the active memory of the computer in the form of objects which have a name. The user can do actions on these objects with operators like arithmetic, logical, and comparison, and functions which are themselves an objects. The use of operators is relatively intuitive. We give arguments and options as an input to the functions, and we get results as an output. Now coming to features of R. It is open source. R is an interpreted language and simple, easy to understand, and it has large standard library, and it supports various graphical libraries and supports multiple platforms like Linux, Windows, and Mac, and it supports cross-platform integration C, C++, Python, and supports matrix arithmetic, and hence it has faster calculation, handling all sorts of data, and supports procedural programming language and object-oriented programming language.
R language is a cross-platform, interoperable and fully portable. We can say platform independent language.
R programming concepts. The basic concepts are syntax, comments, variables, data types, numbers, strings, boolean, operators, control structures, if-else, while loop, for loop, functions, single function, nested function, and recursion, data structures, vectors, lists, matrices, arrays, data frames, and factors, graphics, line graphs, bar graphs, box plot, histogram, pie chart, scatter plot, statistics, mean, median, mode, linear regression, logistic regression, normal distribution, binomial distribution, Poisson regression, decision tree, random forest, covariance, chi-square, and time series.
Now let's talk about R data interfaces.
Sure. Data interfaces serve as bridges between the R and various data sources. These interfaces facilitate the seamless import and export of data for analysis and manipulation. R offers versatile methods for interfacing with common data formats such as CSV files, Excel spreadsheets, JSON files, binary data, XML files, and databases. Thanks for watching. Please like, share, subscribe, click on the bell icon, and please leave the comment. Happy learning. Thank you. Stay tuned to the upcoming sessions.